In this video, I would like to go through all the quoting guidelines. In our CRM system, we have defined groups. Now, it is much easier to think of a group as an item that can be lifted by grabbing it in one place, and then when you lift it, there's nothing that falls apart. So it is the item that is fully welded to other steel items, so that if you lift it up, it will go up as a single item. So in this case, where we have two side beams and then a cross member in between, we have two groups. One of them is B1, which is the member in between, and there's only one of those groups. And then how many beams are there in this group? Well, there's only one beam to make that group. And then if we were to ask how many connections there are in this group, then group B1 has two end plate connections, obviously one on each end. Now, when it comes to the other beams, the ones on the side, they are exactly the same. So there are two B2 groups, whereas each B2 group has one beam inside. And then obviously this group does not have any fabrications. Another example is when we add another cross member, then the number of B1 groups is now 2, but within a B1 group, there's still only one beam. And then similar to the previous example, this group still has two connections. Even though in total there will be 4 connections, but a group has 2 connections and there are 2 groups of B1. Now the other 2 members, there are 2 groups of B2 and each of them has 1 beam inside, and they do not have any fabrications. Even though they have holes drilled in it, those holes have been already allowed for in the cleat connection for the end plate connection for the cross members. When it comes to the drawings that are of interest to us when quoting steelwork, there are a few of them, but the main one that we should focus on always is the structural engineer's drawings. They are quite neat. They show the steelwork. The steelwork will be shown either on the drawings. You'll normally have a thicker dashed line that depicts the steelwork. Sometimes you might have the flanges shown, or basically a list of steels. And it is very important that you work to this drawing rather than the architect's drawings. Reason behind it is because an architect might show steelwork, but it's only to sort of give an idea for himself or for the end client that you probably will need some steel work in this place. And then the structural engineer steps in and he does all the calculations and actually confirms whether there's a steel beam required, and then also specifies the size of it. Beware that these drawings might not be to scale, especially the structural engineer's drawings, although the architect's drawings are quite often to scale, because when they go onto site they take the dimensions very accurately, whereas the structural engineer doesn't really care about the dimensions because they always have a safety factor on top and they always sort of work on the worst case scenario. But for us, again, for quoting purposes, it is the structural engineer's drawings that we should refer to. Other drawings or pieces of information are basic sketches made by a structural engineer. You could use the structural engineer's calculations. A list of steels could be provided as an email, but quite often it is a combination of all these items. But then bear in mind that there's no need to print out any drawings that won't give you any information. Now, the obvious question is where to find steelwork. Well, the starting point is to first familiarize yourself with the drawings. So go through all the drawings that you've received, but print out only the necessary ones, the ones that show some steelwork, the details of the steelwork, anything to do with steel. Next, if there's a list of steel, then go through it, highlight it, and then try finding those items on the drawings. The next step is to go back to the drawings and just skim through. So just using your eyes, just go run through the drawings and just sort of try and work out where the steelwork is, so that in the next step you can visualize the structure and actually start building the whole structure in your head, so that when you go through it, you like understand, okay, so we've got a column here. Well, if there's a column, there must be a beam on top of it. And then if there's a connection somewhere, that means there's another beam coming to it. Do I know what the section is? And so on and so on. And you basically build the whole structure in your head. And obviously also look into details, any side notes, anything at the footer of the drawing or on the side. There could be some valuable information. When it comes to marking steel on drawings, we've come up with a system that works very well, and we use a yellow highlighter to highlight all the beams that are horizontal in space. We use a green highlighter to mark all the columns or posts. And then anything else to do with steel work, we use either a red or pink highlighter, and that could be the galvanizing, any information about bearing plates required, which we need to add to our quote, spreader beams or spreader plates, splice, cranks, columns with holes or holes in beams, any loose angles used as supports, anything unusual, countersunk bolts, HSFG bolts, whether the beam needs to be rolled or cambered, anything that will affect the price or the lead time of the project. Beware to always write clearly. After you've done your job with your quote, there will be an engineer doing the drawing, and they need to be able to easily read the drawings, just so that we don't end up making a silly mistake only because someone didn't write clearly. When it comes to numbering the steel, we've also mastered a system where we first mark all the horizontal beams, then the vertical. But we don't mean horizontal by the fact that the beams will be horizontal, and vertical meaning columns. It means that when you look at a drawing in plan, like shown here, we first go from, we mark all the beams that are horizontal, and only then, once we've marked all the horizontal ones, we then mark the ones that go from top to bottom or in a vertical line. For small projects below 20 beams, you can just simply continue marking them from B1, B2 and so on until it gets up to B20. And similarly to columns, just basically name them C1, C2 and so on. When it comes to larger projects where normally you would have more than 20 beams and it's spread over more than a single floor, then you would use the letter B to describe the steelwork in the basement, G for ground, F for first floor, and so on as shown here. And then sometimes if you have like a mid floor, then it could be an FL, which is lower first floor, or GU, which is then upper ground floor. And the idea when numbering large projects is to always have spare numbers available. So you obviously first start with the horizontal beams, you first number them, and then you go on to the vertical beams. But then before you go from the horizontal to the vertical beams, you always allow yourself some additional spare numbers, and you would normally go to the next 10. So if, let's say, your last horizontal beam ended up as B25, then you would start the first vertical one as B31. So it gives you 6 additional numbers just in case you forgot to found it and you spot it later on. And then also if you are above a 6 in the end, so let's say you've had B26 being the last one on the horizontal beams, then you'd allow yourself another 10 spare numbers. So instead of starting at B31, you would start at B41 for the first vertical beam. Now let's talk through some mistakes that unfortunately do happen. These are the most common mistakes, and the first one is not spotting a double beam. So this is why when you are browsing through these drawings and highlighting them for the first time, use the red or pink marker to highlight anything unusual. And when you see something like here, 2 number PFCs, then just mark the 2 number, because this will then stand out to sort of grab your attention that there's something unusual with this beam. Because as you can see, it is still drawn as a single beam. Similarly here, this is a triple beam, and if you look at the side view, you wouldn't spot it because you'd just think it is a single frame. But then when you look at the cross section, it clearly shows 3 frames, one next to each other, and obviously the description again shows 3 number. So again, using the red or pink highlighter, you'd highlight the 3x or just basically draw a circle around the cross section. Another common mistake is not spotting the spreader plate. So that is exactly why we use the red or pink highlighter, is whenever you see the word bearing plate or spreader plate, just quickly highlight it, so that once you go on to putting in the data into the CRM system, there are much lower chances of you forgetting about it. And it's quite important because a spreader plate is obviously quite chunky and it does cost some money. And unfortunately, as a company, we do not want to cheat. We do not want our customers to be let down. The price that we provide them, we really want this to be the final price. And unfortunately, these spreader plates do add some cost. So that's why we want to be transparent with our customers and let them have the right price from the very beginning. Another typical mistake is basically missing out on a beam, and that's by going through the drawings. So the easiest way to sort of cover yourself is to first go through the drawing, but then go through a list of steelwork and basically tick all this steelwork, just to confirm that there's nothing that is in the list which is not shown on the drawing, and vice versa, that there isn't anything in the drawing that is not in the table. So a few guidelines. Well, how not to miss a beam, and I guess that's probably one of the most important questions when quoting, is after you've highlighted and named all the beams, but still before you start entering all the data, check the steel list. So like I've described previously, go through the drawings, go through the list, and just make sure that everything matches. Next, sort of even move yourself a bit further away from the drawing so you're not stuck with your nose in it. Just move it away, and again, just run through it with your eyes just to scan through whether you haven't missed anything obvious. And again, now because most of it, or hopefully everything, is highlighted, you should be able to build or visualize yourself this structure in 3D much easier. So just ask yourself the question whether what you are visualizing makes sense. Another common mistake is not adding spaces for double beams. So whenever you have double beams or 2 number or trebled up, there are very high chances that there will be spaces required. And like described in the connections video, one fabrication is 1 spacer. So you'd have to add the quantity depending on how many spaces you need for a particular beam, bearing in mind that they are normally spaced at 600 millimeters from each other. Now, a very easy mistake to do is not to add a plate, a bottom or top plate, and unfortunately they are quite expensive, especially when you start adding the fabrication costs. And like just described, we do not want our customers to first have a lower price and then we have to go back to them and explaining that we've actually missed out this plate, because they might think that we've done it on purpose, and that is not the way we operate. So here you can see that a bottom plate is very often, probably almost always, used for the back wall where the steel work is supporting the rear wall, creating a new opening. Because this beam is used as a lintel, so it bridges the gap above the opening, and it is used to support the outer leaf of the wall, which is the brickwork. So that is why there's a bottom plate required. So the beam itself takes the load, but then the bottom plate supports the bricks. Another common mistake is not spotting that a column needs to have tabs welded to it. Another very, I would say, even serious mistake is not spotting the fact that a beam needs to be cranked, because this significantly increases the price and also requires our customers to send us a timber template of the shape of the crank. So on the plan drawing, you won't see anything unusual, because no matter how the beam is cranked, if it's cranked in the vertical plane, it will still be drawn as a single line. Whereas obviously there are a lot of implications. And when putting in the postcode, really take care of which postcode you are picking, because you might find two postcodes, one being the correct one, which is the site address or the site postcode, and the other one might be the address to the engineer. And obviously we do not want to send our steelwork to the engineer because they will be very surprised. We want our steelwork to be delivered to our customers. Another quite serious mistake is not spotting the fact that some or the entire steelwork needs to be galvanized. There is a significant price impact if the steelwork needs to be galvanized, and it also impacts the lead time, because it takes around 3 days just for the galvanizers to collect it, carry out the process, and then sending it back to us. Now, where can you expect galvanized steel? Well, anywhere where it is exposed to the weather. So rear lintels of extensions, because the outer edge of the plate will be exposed to the weather. External steel work, anything that will be exposed, so quite often posts. Columns that are in cavity walls, that's because there are high levels of moisture in cavity walls, so they need to be galvanized. Sometimes you might come across PFC sections being used as gutters. So obviously they will be full of water, so they need to be covered, galvanized, and other features like window frames or any other supporting frames. Now, to spot the fact that steelwork needs to be galvanized, there are a few possible descriptions on the drawings. It could be the full word galvanized, it could be abbreviated like galv. There could be a note on the schedule of steel or the list. It could be somewhere embedded in the notes section of a drawing, or you could find basically somewhere a sentence that says that all external steelwork to be galvanized. And bear in mind that this is not intuitive, it is sometimes hidden. So that is why we really strongly emphasize the fact that you have to highlight anything unusual in red or pink. Another issue is when we do not add lifting to our quote, whereas the customer specifically asked for it, because obviously there's a price implication, and obviously it also allows us to plan accordingly, because that means that a project that needs to be lifted needs to be delivered on a vehicle that has the right crane on it. When it comes to steel specification, you might find these notes, but then the typical requirements are for the steelwork to be primed. The grade of the steel needs to be 355 for the main steel sections. It will differ for steel plates and for the flat sections used for, let's say, lintels. Obviously, the steel needs to be fabricated to British standards. Normally, the bolts, if they are not HSFG bolts, they are 8.8 grade. And the fact that there's a requirement for the steelwork to be shop welded means it has to be welded inside a fabrication plant, which is exactly what we do. You might find these notes quite handy for the customers. So like here, you might point out that you couldn't find some of the beams that were on the schedule, but just to make the customer aware that if we somehow find them, or maybe the structural engineer will specify where they are, the fact that he forgotten to show them on the drawing, then we'll add them to the quotation. And also any other notes, like the fact there's a steel angle or side welding, or the fact that you worry that one beam is a bit too heavy, and then you suggest that maybe adding a splice might be a wise thing to do, but then the fact that this is not included in our price. And also you might also specify that if you're not sure with the scaling, the dimensions of the drawing, then just point out that the quotation has been done based on the dimensions being scaled off the drawing, and if they will significantly differ from what will be provided at a later stage, then we obviously reserve the right to amend our quote. When it comes to ordering material, we are constrained with these sort of requirements, where for the typical sections, the UC, UB and PFCs, we can order any length. It is cut to length by our suppliers, and we don't pay, or normally don't pay, for the offcuts. When it comes to flat sections and all the angle sections, we have to order them in 6 meter bars. And for the hollow sections, it is either 7.5 or 12 meters. So with the last two, the 6 meters and the 7.5 and 12 meters, it is very important to note that if we need only, let's say, 2 meters of a very unusual angle section, we will still have to buy in the 6 meters. And unfortunately, this needs to be shown and added to the quotation. Now, if you don't know the height of a column because it is not shown and this is just at the quoting stage, then you can easily allow for 2.8 meters because that is the standard height of a column. Now, this graph shows the typical order process. So everything starts with an inquiry from a customer. It could be by email or by phone or by simply walking into the office. Next, we do the quotation, and if it is accepted, we then sort out the payments. Quite often is a full payment up front. We then do the drawings and order material. So this is actually done in one stage. Then we fabricate the steel. If it needs to be sent out for galvanizing, we send it out. If not, we load it up and deliver to our customers. And if this is just a stage of the whole project, it goes back to the next stage payment and then through the process all over again. But if it is completed, then we basically file it away. When it comes to quoting, it is important to note that without a quote, there would be no project. So this is the beginning of every single project that we do. Now, like I've mentioned, we are proud of providing the best possible service. We are transparent and we sort of have our ultimate goal to have our quote very accurate. So everything must be included in the quote because we don't want to operate in a way where we knowingly do not add something just to have a lower price, get a deposit, and then tell the customer, well, actually, you need to pay for some extras. We hate it, and we do not want to treat our customers that way. Our quotes are itemized, so there are no hidden costs. Everything is exposed. We list all the steels, the lengths, the quantities, the weights. And then also when it comes to the fabrications, they are all itemized. So every single fabrication will be listed. And then also with our delivery, with our lead time, with all the rest, it is all written out clearly so the customer has no questions. We also sort of want our customers to be well impressed with our service. And it doesn't mean delivering the steel work that fits. It also means responding to their inquiry as soon as possible. So we obviously adopt a rule where it is better to sit and have nothing to do, and as soon as an inquiry comes in, we jump onto it and quickly quote it, rather than being full of quotes and bogged down with many other things to do. We want you to quickly have a clear mind and then jump onto quotes as soon as possible. And you've probably noticed that accuracy is key. It is much better to provide an accurate quote at the very beginning, so that we don't have to then have a silly conversation with our customers. And like I mentioned at the very beginning, without quoting, we would not have any work because we simply wouldn't be able to accept an order. So when it comes to our service, we do only structural steel. Therefore, we do not do architectural metalwork, so anything to do with stairs, balustrades, balconies, and other items. We do not do reinforced bar or rebar, as it is called. We do not supply catnic lintels, and we only get involved in installations when we are doing a large project. So if there's a small project, we basically would not install it. And then when you quote, you only need a few items. Well, you obviously need access to the internet so that you can use our CRM system. Then you need highlighters, yellow, green, and red or pink. A ruler, which might be handy to scale off drawings, a printer, and you might use a tool like a PDF exchange viewer, which sometimes it's easier to scale off those drawings than it is by using a ruler. And we've also have a very handy quoting procedure. So step by step, by following this checklist, you have probably 95% chances of delivering an accurate quote without missing out on anything or without forgetting to add a specific item, which could end up being very costly to our customers. Thank you very much. If you'd like to connect and watch future videos, then please sign up to one of our platforms. Thank you.